and start talking about our next unit, Unit 3, which I'm so excited about, parallel lines. All right, so here's the thing that I want you to be thinking about while we're talking about and reviewing for the quiz today. It would be a really good idea for you to have this piece of paper out, because this pink piece of paper, that's your approved pantry. If we talk about any justifications, if we talk about any reasons for why we do what we do, and you don't have it listed in your approved pantry, then it would be a good idea to have them. So the approved pantry doesn't necessarily put things in a neat equation format like you might think there, properties plus definitions plus postulates. So those ideas don't exactly equal my vertical angle theorem. What it is instead is just a listing or resource. So just like when I'm looking to figure out ideas of what to cook for dinner, I might go into my pantry and just stare and hope that some ideas come to me. Or when you're hungry, you open up the refrigerator and you just stare, hoping that something good to eat will jump out at you. If you are struggling on the proofs, this is the #1 resource for where we go. So if in the course of our reviewing these conversations, if we see a justification or talk about a justification that's new to you, hey, add it to the pantry. Make sure you have it listed. So you each have the keys in front of you. Number 1 was all about your steps for justifying. Hey, what did you think about the one where you multiplied each side by 100 to get this value, that equation, out of decimals? That was a pretty interesting strategy. When we're talking about our second proof, understanding our angle addition postulate, our substitution property of equality, and then how we go ahead and combine like terms, subtract and divide. For number 3, we recognize that if we're given distance from K to L is 3 times the distance from P to M, notice my substitution property lets me put those algebraic concepts in and solve. Number 4, if I'm given those 2 segments have the same distance, my substitution property allows me to go ahead and take care of that. And 5, 6, 7, and 8 name the property of equality or congruence that justifies going from the first statement to the second statement. If any of those things listed on both my answer key and your answers are not in your proof pantry, take the time to add them so that you have that as a resource. Would you please talk to your group, and would you talk about anything that you want to add to your pantry after looking at my key at your homework? Take a minute and talk. Go. All right, so again, we want to make sure that when we are looking at our proof pantry, it's just a listing of all the things that we've learned so far. It's kind of like a summary. So instead of going through your entire notebook and flipping through and wondering, what have we learned so far, all of these definitions, the feedback I get from kids is when they say to me, how am I supposed to remember everything? Definition of right angle, definition of midpoint, definition of congruence, definition of perpendicular, definition of right angle. How am I supposed to remember all the things that you've taught us? It's too much. So this pink piece of paper provides a place for you to just list it all. Now, if you have something written down and you don't know what it is, that's a lousy resource for you to use. So that's the difference between copying what the teacher writes and understanding the notes that you are taking so that you can do what needs to be done in a quiz or test situation. What does VA theorem stand for? Vertical angles theorem. It's one of our first theorems that we were given that we can talk about how to prove. All right, back to the homework. When you look on the back of the page, you had a couple conversations finding the value of x. All of these are vertical angles. Our vertical angle theorem is the one that says because vertical angles are congruent, you can go ahead and set each of those expressions equal to each other and solve. Now, if you look at 7, 8, and 9, your key only has half of the answers. You were asked to find the measure of angle 1, but once you go ahead and find that measure of angle, once you go ahead and set angle 1 and angle 4 equal to each other and solve, you need to take that value for x and plug it in order to figure out the measure of angle 1. So for number 7, x is equal to 30. Measure of angle 1 is then going to be 150. Number 8, when you're looking at the measure of angle 1 and 4, you end up with x having a value of 34. So when you plug that in, correct me if I'm wrong, was it measure of angle 1 then 152? Does my memory serve? Was that number 8? Or am I thinking of number 9? Number 9, when you know the measures of angles 2 and 3, you then have to go ahead back and use that to help you find the measure of angle 1. So your key, I don't know if if yesterday's class updated that like I asked them to, but I want to make sure that you know what the measure of angle 1 is in each of those scenarios. So the measure of angle 1 in number 7 is 150, number 8 is 152, and in number 9, 108. All right, in number 10, you have a proof, and you're given that A and the measure of angle BDE are congruent. Those two angles are congruent. So statement number 1 is your given. Statement number 2 is where you talk about vertical angles being congruent. Statement number 3 is where you go ahead and use the transitive property of congruence to get A and CDE equal to each other. Then you convert them into equal measures, which then lets you substitute in and then do your equation solving. What questions do you have on that proof? Go ahead, Maggie.
For the reason for number 3, could you also use the substitution property?
No, and here's why. You can only substitute numerical values. So typically the transitive property of equality and substitution are interchangeable because equality is numerical values, and we can justify that as substitution, absolutely. But if I am comparing congruent things, I have to use the transitive property because I can only substitute numerical values, measures. Good question for the smart ant. Any other questions for this worksheet? All right. Would you please elect one group member to collect the keys and return them to my basket? And then I'd like you to take out your proof jigsaw, please. So take your proof jigsaw. Okay. Proof jigsaw's out. Thank you. proof done. You were supposed to check in with that color proof, and then you were supposed to find a group of one of each color, and you were supposed to help each other and teach each other the proofs, and then you were supposed to work on the rest of the packets. So Abdullah's sitting here shaking his head. So whether that did or did not happen, you were then supposed to, for homework, recognize that the key and videos were supported and posted on Schoology. I'm waiting for him to nod. The key and videos were posted on Schoology. All right. So page 1, front back, had my yellow and green group proofs. Any questions for these that you want me to talk about or go over? All right. Page 2 had my pink and purple groups. Any questions from these that you want me to talk about or go over? Go ahead.
Just clarifying, the line was the line on top of perpendicular.
So this symbol here means perpendicular. So this symbol here that looks like this, it means that those two lines are perpendicular. If two lines are perpendicular, by definition of perpendicular, that means they intersect at right angles. By the definition of right angles, you know that the degree measure is 90. So that's going to be some important information for you. Anything else I can help you out with?
Just like having the proof, because like I know what it is 90, but like it's like a line, like two perpendicular lines, but I just say like 90 degrees to both.
So what ends up happening is when we're talking about this idea about it being perpendicular, and this proof is a little bit tricky because it's hard to tell what it is you're proving. So you have to recognize that if this is true, then this is true, and this is what you're proving to be true. So if line AB is perpendicular to EF, then you have a right angle. If it's a right angle, it has a measure of 90 degrees. Both of those are by definition. So then I know that I can prove down here in my body of my proof that the measure of angle 1 is equal to 90 degrees as an outcome of those two definitions. When I get to my second part, CD is perpendicular to EF. Once I know that line CD and EF are perpendicular, then I know that I have another right angle. And because they intersect at a right angle, I have another 90-degree angle, so that's going to be my measure of angle 2. And then because they're both equal to 90 degrees, that's how I get them equal to each other. Okay. All right, so would you make sure that your name is on your proof jigsaw? And would you, every group member, just place your jigsaws on the baskets, please, of your table group? So when we're talking about these parallel, perpendicular, and skew lines, we need to revisit. You have highlighters and colored pencils in your baskets, so join me in interacting with this picture in a way that reviews these important terms to you. If I'm looking for a line that's parallel to PQ, here's PQ, and I need it to contain point S, here's point S. That line that's parallel is going to be line ST. A quick reminder, when you're talking about a line, capital letters for S and T, and your symbol at the top has arrows on either side, showing you that that is a line that goes on forever and ever in both directions. If I'm looking for a line that's perpendicular to PQ and contains S, we're going to go ahead and go with line PS, recognizing that that face of that prism is constructed of rectangles. See the question, Christian?
SQ is the same, right?
Yes, SP or PS are the same line. Our reflexive property tells us that. All right, if I'm looking for a line that's skewed to PQ and contains S, we're looking for a line that is never going to intersect PQ and contains S. So we're going to have to go with this line here that scoots down the back of the figure, and that's going to be line SU. A skew line is going to be one that never intersects, and it's in a different plane. There's a difference between a parallel line and a skew line. Parallel lines never intersect because there's the same distance between them all the time. Skew lines behave in a completely different space. When I talk about the name of the plane that contains S and appears to be parallel to plane PQR, plane PQR is going to be this face of this shape right here. So if I'm talking about the one that contains S and is parallel, it's going to be that other face. When I go to write the name of the plane, you only need 3 letters. So we can call it plane S-U-T. And if you called it S-T-U, that's fine, or T-U-S, or T-S-U. It doesn't matter as long as those 3 letters are included. Turn to your partners, please, and talk about which one of these 4 you think is the trickiest of questions to find for you. And your mark, set, go. All right, come back. So looking at the bottom, today we're going to introduce this new vocabulary word, and this vocabulary word is going to be a transversal. And a transversal is a line that intersects 2 or more lines. And we're going to talk about all the cool relationships that exist between these angles, but first of all, we want to review the relationships that exist between intersecting lines. When any 2 lines intersect, they create a little bit of a family of angles. So when you look at angles 1 and 2, and 3 and 4, they have some cool relationships. When you come back from lunch, I want you to dive into and finish this side. Okay, so these 3 words, 4 if you count linear pairs, 2 words. These 3 vocabulary terms, linear pair, supplementary, and adjacent, they go together. They describe 2 of those problems. Which ones? Numbers 5, 6, 7, or 8? So 5 and 6 are going to be a linear pair, and they are going to be supplementary. Numbers 5 and 6 are going to be, angles 1 and 2 are a linear pair. They are supplementary. The angles are adjacent. 1 and 3, the angles are a linear pair. They're supplementary and adjacent. Rachel, what's on your mind?
It's also correct if we put an
Yes. So here's the deal. A linear pair are two angles that are both supplementary and adjacent. The reason why I like this answer better, because supplementary is going to help me solve for whatever angle measures I'm missing, adjacent's not. But to be honest with you, linear pair has it all covered. If two angles are a linear pair, by definition, they're adjacent and they're non-common sides or opposite rays, and that's what then, by the linear pair postulate, makes them supplementary. How would you describe angles 2 and 3 and 4 and 1? What vocabulary word would you use?
Vertical.
They are vertical angles. Give me another vocabulary word. Yeah, those are going to be congruent. Vertical angles are going to be congruent. Did you maybe use the word opposite? Because opposite angles are also going to be congruent. They're the result of two intersecting lines. So what's interesting is everything within that family is either opposite and congruent or adjacent and supplementary. Do you see that? So with your partner right now, go fill in the information about angles 5 and 6, 5 and 7, 7 and 8, and 6 and 7. And your marker set, go. Do we agree?
Yeah.
Okay. So here's what's important for you to recognize, that each of those angle families is created by an intersection of two lines. When that one line intersects two lines, we call it a transversal, and we're going to start talking about angle relationships between these two families. On the back of this page, give yourself a little HW, and tonight's homework is going to include finishing and reviewing what we're talking about with parallel, perpendicular, and skew, and those rest of those vocabulary words. Sound okay? All right, next up. So go ahead, take a minute and scroll down and look at each of those vocabulary words. Parallel lines, perpendicular lines, skew, parallel planes, and right up until this line here, those are all the same review terms that we just talked about. Transversal we mentioned, and then all of a sudden we have all of these different angle relationships. So what I want to make sure is that you have, if you need color pencils or highlighters, that you're with me and you're ready to go. All right. When we draw a set of parallel lines, we'll go ahead and we'll draw two lines in the same plane that never intersect. They have the same distance from each other. Hey, this is what we like to do. Sometimes it's easier to name the lines with lowercase letters instead of points. So then we can just say that line A is parallel to line B. So we want to make sure that you understand this symbol here, which means parallel. The other thing we need to make sure that you understand is if I want to tell everybody that these two lines are parallel, if I draw two little triangles on the line, and notice, then that means that those two lines are parallel. So you need to know the symbol of the two little parallel lines, and you need to know the triangles. And by the way, if you look at the word parallel, you can see that symbol with the L. So if you can't remember, maybe that might help. All right, if I talk about perpendicular lines, perpendicular lines are going to be lines that intersect at a right angle. My symbology is going to be a little box in the corner, and that box is the symbol for a right angle, which we know by definition measures 90 degrees. I again can name the lines with lowercase letters, and then my notation would be A is perpendicular to B. So this symbol here means perpendicular, that symbol there, perpendicular. So skew lines are lines that are not in the same plane, and they never intersect. And if I'm going to take the time to draw skew lines, it helps if I give myself a 3D figure. So go ahead and draw a square-ish figure. Draw 3 spokes coming out that are the same length at the same angle, and then connect them for your 3D figure. A dotted line will help you see what is in the back of the figure that we can't see. When you're drawing skew lines, you want to draw lines that are not intersecting and lines that are not in the same plane. One of the other geometry teachers teaches his kids, it's like an overpass on a highway. So picture this being a road that a car will drive on, and then this being an overpass that another car is driving on. Skew lines. Not in the same plane, never intersecting. A 3D figure helps you with parallel planes. So if you didn't do so great with your 3D figure, try again. Draw a box. Draw diagonal lines at the same length, and that can help you draw that 3D figure. Parallel planes are going to be planes that never intersect. So when I draw like the sides of my box, picture opposite sides. A tissue box ends up being the perfect example of parallel planes. If you hold it in your 2 hands, parallel planes are going to be these opposite sides. Parallel planes. All right. When we start talking about transversals, a transversal is going to be any line that intersects 2 or more lines. So I have my 2 lines here. If there's 2 lines, it'll form a system of 8 angles, and we're going to talk about those angle families next. So your transversal is the name of this line that has those 2 intersections. All right. So corresponding angles are going to be angles that are in matching positions. And by matching, I mean they're going to be on the same side as the transversal and in the same position with respect to the other 2 lines. So if I draw my transversal, I keep trying to make it straight. So if I have my transversal here, if I look at angle 1 and angle 2 here, they're both in matching positions. They're on the same side of the transversal, and they're both sitting on top of their little line. So if I have this line here and this line here, I can say that angle 1 and 2 are in matching positions. Those are what we call corresponding angles. They're in corresponding positions. All right, if I take the time to draw my 2 lines, and again with my transversal, when I talk about alternating exterior angles, that's going to be two angles that are on opposite sides of the transversal, and they are outside of that line system, alternating exterior angles. So we're not very creative when we name things in mathematics. So alternating exterior angles alternate sides of the transversal and are outside. So what do you think alternate interior angles are?
On opposite sides.
So opposite sides of the transversal. Keep going. And they are inside. So if I have my two lines here, and I have my transversal here, if I have opposite sides of the transversal and inside in the interior of those lines, those would be our alternating interior angles. What? Again, mathematicians are lacking creativity. So when I draw my parallel lines, no, just any old lines, and my transversal, our next side tells us exactly where they are. Same side, interior angles. Those are going to be angles that are on the same side and interior. We call them consecutive. The word consecutive means right next to each other, one after the other. So when we talk about this word consecutive, that means next to. One right after the other. So our consecutive interior angles. Your math space talks about consecutive exterior angles. I'm not fond of this one because to me, consecutive exterior angles, they're not really next to each other, but I will buy consecutive or same side exterior angles. You had to argue and say, well, wait a minute, they are the only two exterior angles that are next to each other, so maybe you would buy that. All right. So while you're catching up on your drawings, here we have one line, here we have a second line, and here we have a transversal. And if I took these two things and I put this one here and this one here, what kind of angle pair are they? Who said corresponding? How come? Same side as the transversal and in the same position. All right? How about now? Consecutive interior. Oh, Maggie, go put Smarty up. Olivia, go for Smarty up. Consecutive interior, same side and inside. How about now? Alternate interior. Abby, go put Smarty up. Those are alternating sides of the transversal and on the inside. How about now? Alternating exterior, Ethan, I heard it. How come?
Because they're on alternate sides of both exterior angles.
They're on alternating sides of the transversal and exterior. All right, here's my favorite. Not.
Consecutive exterior.
Consecutive exterior. What do you think about that? Do you think there's another consecutive exterior? What do you think? I don't know.
Yes.
Hey, did everybody get a note sheet while I'm walking around? Yeah, who said consecutive exterior? Who said that? Go put it up. All right, what are these sides? Hurry.
Those are
Hurry, hurry.
alternate exterior?
No.
Corresponding. What are these guys? Alternate interior angles. What are these guys? What are these guys? What are these guys? Vertical. What are these guys? Adjacent, supplementary, so they are a linear pair. Very nice. All right, on to, do me a favor and put a little HW here, and then move on to our next note page. On the back of the notes is the homework. And then here we are on 3.1b. Hey, this is what we've been going for. And if you'll notice, you're like, wait a minute, what's new? I'm so confused. Because here's this same turn corresponding. Here's this same alternating interior angles. Here's this same consecutive, same side. And here's this same alternate exterior. What is different? And with your highlighter, I would like you to make sure that you let everybody know what is different. What is different about each of these pictures? What do you think? Yeah, these lines are parallel. So now I know for guaranteed certain sure that these two lines are parallel, the same distance between them at all points. So when I have a transversal intersecting these two parallel lines, I get some pretty cool relationships. The difference between a postulate and a theorem is the postulate is what is given to us, and the theorem is what we need to be able to prove. A postulate is what Euclid says. Here's what Euclid says. Hey, if you have two parallel lines, and if you have a transversal, corresponding angles are always going to be congruent. Angles that are in the same position are always going to be congruent. Now, I just marked one set of corresponding angles. True story, there's 4. I showed you these two angles that are on the same side of the transversal and on the same position to their line, but you know that there are 1, 2, 3, 4 sets of corresponding angles created by those 2 parallel lines and that 1 transversal. I'm just showing you one to keep our notes a little neater. Does that make sense? Using the corresponding angles postulate, which says if you have a transversal intersecting 2 parallel lines, then all the corresponding angles are going to be congruent. Using that, we can say, oh, by the way, not only are corresponding angles congruent, but so are alternating interior angles. And scoot down to the bottom, alternating exterior angles. And you're like, well, what about our same side interior angles? What's the story with them? What do you think, if you had to be a guesser, since everything in angle land is either congruent or, what's the other word that we use to describe angle pairs? Supplementary. So when we talk about consecutive interior angles, they're going to add to 180 degrees. If the lines are parallel, then same side interior angles are going to be supplementary. Hey, guess what? Our same side exterior angles are also going to be supplementary. We can start to think about in our head how we can prove this. and it's a simple conversation, I want you to think about this angle here. What is this angle's relationship to the red?
It's, alternative extremes.
Alternate exterior angles. What is this angle's relationship to the black?
Vertical.
What is the black's relationship to the red?
No.
Corresponding. So if black and red are corresponding, and Euclid says, hey, all corresponding angles, parallel lines, they're congruent. If red is congruent to black, and black is congruent to white, what do you know? Transitive property of congruence, right? Red is congruent to black, black is congruent to clear, right? Transitive property says, okay, so that's how I know alternate and exterior angles are congruent. Ready? Let's go again. Red is congruent to black. Red is congruent to, what do you know these about these two? What angle relationship do you see? Think about it. Alternate interior angles are going to be congruent. Hey, flip over to the back side. Write a little HW here. You have 3 backs of the note sheets to do for homework, plus a math space. The math space is super quick. It's just this kind of stuff. Do your homework, please. Be ready for next class. See you.